tragic. This is like the fifth time I've started. This time I just realized I wasn't even recording. But on the plus side, I was muted because I keep trying to play these videos and then talk, but I don't want to mute myself. I don't want my sound to go through because it sounds better if I mute myself. So I'm trying to mute myself. So hopefully this time I make it through these 3 videos appropriately muting at the appropriate times.
There's no way the critics said that the glacial ice is going to be able to retain that much water under that much pressure to accumulate. Yes, to accumulate the mass of water, the volume of water required for your huge subglacial floods. So, in essence,
holy paradox, Batman.
Holy paradox, Batman. Yes, I'm glad you saw that, Russ. You picked up on that immediately. Yes, the little contradiction here inherent. So they said, well, you can't provide any source for this scale of subglacial flood that you're talking about. So therefore, they didn't happen. And the idea has not been accepted by the geological mainstream. They're still floundering around trying to come up with some kind of way that the glaciers themselves are shaping the glacial till into these beautiful, streamlined aerodynamic forms. See, there's no.
Okay, so that's a good intro. I did it. I did it thus far. That's a good intro for these 2 episodes with Jerome Lessman, who was on Nick Zentner's channel several times. So we've been talking about, I made this animation recently. Maybe let's play this. Well, maybe we can start here. Unfortunately, okay. There's a current flowing that way, influencing this region with the Columbian River basalt. This is a current of water in the ocean as the accretions of the terrains here accrete onto the Laurentian craton, and it closes this gap. The current comes through and etches through this region, creating the Columbian River basalt as well as Missoula flood simultaneous. It's just dated by different methods. And so this is going on the West Coast, but recently I added this one where we start with that, as well as continuing it down here, I think, generally, and then having other currents that are there. So we're talking about, like, this one doesn't appear to match what I've seen so far, but these 3, I don't know if there's anything especially counter to it. Maybe that one as well. It seems to be happening, I'm just not sure what the boundaries of it all is. Like, it might have a flow this way, based on drumlin data. So we have essentially mapped like a continent-wide water flow. Mind you, this is happening while all of the continents are conjoined as one landmass without oceanic crust before the Earth expanded. And so the water on the Earth is on the continents. So it's flowing on North America. But then the Earth starts to expand. And so it has like steps in which it expands and stops. It grows and stops and grows and stops. And along the way, it influences this water, like it drains out when there's somewhere to drain to, but it seems like the Earth itself is emitting water so that it's accumulating in the oceans, so that it still stays above the surface here and then like replenishes even at some point, and then it expands, maybe even expands the first time largely at like the Permian, and then a second time at the KT boundary, where the first time the water accumulated and then it expanded somewhat at the Permian Triassic boundary at like 252. I don't know if I'm just spitballing that. it seems to make sense, although it also did it more so incrementally. Like each extinction event was tied to a step in the Earth expanding, where the KT boundary was the one that really broke the continents apart so that the ocean floor could stabilize by filling in the space. Okay, so all this stuff's going on, and I'm watching this stuff with that in mind. So Randall Carlson is talking about the evidence for subglacial currents of something subglacial water flow that's flowing and etching the surface in ways that science presently doesn't acknowledge. And his interpretation draws from, well, this is, I believe it's a impact that then melts the ice and leads to this outflow of water in huge quantities because of the sheer quantity of water that's outflowing. It requires a sufficient impact to have put that much energy in, and that's basically the line of reasoning, is that the impact put that energy in. But my thoughts is the Earth expands, but before it expanded, the Canadian Shield was already an ocean on the pre-expansion Earth. So it was just hanging out sort of like over here. It was much like the Western Pacific, where it was the optimal place for an ocean then, before the Earth expanded. So there still was an ocean. It was just on the Laurentian plate and other places. Probably also over here. Possibly places that have that appearance especially. I'm not sure. I haven't really been able to determine the full extent, but it's certainly up here. And so it was already a basin for water to flow to. So when water started to accumulate before the Earth expanded, it just kind of went towards the basin. So with that in mind,
this is kind of the controversial parts of it. The most controversial part of this argument in this calculation is the width of the flow.
Mhm.
It's really truly, is this truly a 70-kilometer wide flow? I mean, if you try to picture that, this is not in a well-established river channel or something like that. This is a transient event where it would presumably be potentially, I mean, if you go from the mapping, 70 kilometers wide, right?
Which is about 45 miles roughly.
45 miles wide, moving at a velocity that moves everything or strips away everything except the largest boulders we saw in those photos. So, I said
this one I had to cut off. The next one clipped well.
earlier that the meltwater hypothesis is not something that is widely accepted. It's controversial, and part of the controversy stems from the fact that the implication of recognizing that some of these forms might be made by water creates very quickly a need for absolutely staggering amounts of water. Like the volumes of water are incredibly large because Georgian Bay is one small part of one of those flow tracks that I showed you on that map earlier, right? It's a very tiny portion of the entire map of drumlins and streamlined landforms across Canada and the Laurentide ice sheet. It's a relatively small area compared to the full size of the ice sheet. And it still requires a discharge on the scale of Glacial Lake Missoula.
Mhm.
Okay, so he was talking about this map, which shows the flows more precisely. This is really interesting. There's this point here where flows are going this way, flows are going this way, this way, this way, this way. this way, this way, this way. Like they're all flowing out of here. Like almost like it was a nucleus that it spawned from over here. Whatever the currents, like a shallogram, like a current that went out and then up, over and back through, and then like pushed out and then kind of turned around here. Like up, went up here, maybe to a degree, where like a portion of creating some change in the energy flow, where then it went over top the ice and back atop and then drained down while extending outward. Like meanwhile the currents are pushing forward, but there's enough resistance to keep that kind of thing going. Maybe that would be so cool. That would be so cool. They somewhat follow the shapes I have in that in this. I've made so many videos messing this up that I forget if I played this already. But I generally intend the currents to be moving in the direction that I draw them. Like my interpretation is such, especially like that one that goes into there. Although I guess it's possible it could be the other way. But so like this though, voila. I should have left a few seconds because it just fades away. Like the arrows from here are pretty interesting, this thing. Like they're going out this way, but they're flowing this way. So it's almost like there's a outflow with a over the top flow that's coming in, like a flow of, yeah, coming in over the top of some kind of underflow that's the boundaries of the flame. Like it's flowing in this way to a degree, but then there's a flow atop it coming back this way that's basically going up over it and then sloping down its sides until it gets down to here, where it then flows out. And also some of it probably feeds back into the system, creating like a living flame of ice. Whoa. Whoa, dude. Whoa. Because it's generally going out from it beyond its boundaries. And even generally has a flow. I don't know how exact the data is, like how many drumlins are considered to draw each of these lines. I'm sure it's pretty substantial, but I wonder, because I see this right here. I don't think I'm making up that there's like a general trend of like a thread that's not present around it that goes through here that just points at here to a point that it suggests like a threaded connection that would maybe be more apparent in the drumlins. Although, yeah, like they're bending like this way based on this. individual ones maybe are, where like the cross current creates a structure across it that goes down to here, but like there's a overall current going more sideways like this that's creating the threading, maybe. Over this way. This is interesting. What? I guess they're just not up there. Because that area, oddly, if you look closely at the directions, like these have flows going this way, this way, this way, this way, which we talked about before. And then over here they start to rise, and then they really start to rise, and then they go this way, but rising, like rising, rising, rising over this way up to this point, and then above this, wrapping around, going over this way. I would expect there to be some drumlin. Like this shows a clear current pass. I don't understand. What's going on with the geology? I think it's legitimately a religious issue where admitting to the scale of flood that is obvious is too inviting. Do you guys see that right there? I think you must see that. I can definitely see that. Right here. Oh yeah, it's definitely there. The reason that was interesting, it looks like there's a larger boundary around it, is very much in this line. And with that even, possibly something there too. Just by the line. Oh my god. That reminds me, let's check out this real quick. Air, wind, let's go up high. Zoom out a bit, we're next to India. You can kind of see some circle. There's a cyclone here. It's near Dwarka, near Girnar, near a lot of things I've been studying. So it just drew my attention in general, and then I was looking at this map, just thinking about like what's going on. Noticing here, for instance, there's going this way and then going opposite, and between them are these little teeth. Made me think of shallograms by the interactions of adjacent currents. But back here, it's just flowing atop. Mind you, there's a cyclone, and I thought there's a vortex weapon used on ancient Dwarka that expanded or stretched to space and brought space in, so it would probably be detectable at this point. So I was just kind of thinking, like, I wonder what it looks like if we start dropping down. And here, what's really interesting about this, a current coming in, and then it goes around in a horseshoe pattern, and it fans out, which is how he describes drumlins as a result of current flows in this video here. Showing the fractal scale invariant nature. Some more. Trying to find the slide. This is a real good one here. Just the detail, like demonstrably done by water, cannot be the result of glaciers because they would just like break pieces off. It would be much more broken, not caressed by a current flow that was clearly sustained. Like let's say a current was flowing that did like this. Like it did like this a lot to a point where it etched out boundaries. I'm not saying that's what happened in this instance right here. I'm just giving an example that the current stabilized. They didn't just like vibrate in ways to like uniformly affect everything. They stabilized and like going the same way, kind of like this. Like it's going this way, and underneath the flow is this getting etched by it, basically. So notice the fanning out. It's literally doing it at the top of this cyclone that we can only detect by this, which is really interesting. It makes me think there's an element of drumlins that is like related to that. So here, interestingly, he describes it as a horseshoe vortex. Even so, it's even associated these things with vortexes. Crazy. Comes in, divides around a resistance, obstacle. Current comes in, hits an obstacle, divides around it, creating eddies that etch around it. And then instability, so I guess turbulence up here that widens and creates it fanning out or something. I don't know exactly. But we're seeing it right here. Just curious. And whoa, now we got ourselves a full-blown cyclone. So here we barely notice, but if we think about it, I guess this spot is like running into resistance of some rigid system relative to the particles that are flowing more freely, and it slows down the flow and it physically starts to drop down this column where then it starts swirling around it, still with the flow across. Although I've noticed like there's changes between layers. It's crazy. The potentials of like really thinking about what's happening in that regard from just airflow. So let's move to the next one real quick. Notice it's pretty much just a spiral now. Even more so, more circular. Sorry guys to use what's happening. More circular and more circular, maybe even more like pointy, like coming to a tip. Undetectable pretty much, although this is just, it's interesting how it looks like fabric flowing. barely noticeable by it, just its effect on the surroundings. We can even see outer edges of it. And then boom. And what I thought was interesting is this is a kind of transitional step. Like it's got the main spiral, but then its current is going out here into these other eddies that make it much more maybe ammonite like. I was thinking like maybe this is pointing to some aspect of how ammonites form, like maybe here. Outer one, I don't know. Because then it just becomes a spiral. I'm thinking of it almost like cross sections through a shallogram. Just not sure. Or an ammonite, I guess. Here's just a flat layer on top. Then it's like the bulge. Like if you find an ammonite, like it can have a layer atop it, like further up, and then the bulge where current flows like hit the bulge and flow down. Like here. And then they start to go around it. Bringing currents to like the center. Maybe even creating like a shell. Still has a bit of an ammonite shape here along the side. I feel like there's potentials here. But so let me finish this one. I'm like, oh god, I was unmuted.
But nonetheless, you can't, like, the question of the water is a perplexing one. I mean, it's a big one. It's a big open question that needs to be addressed one way or the other. Either you got to find a way of having that much water, or perhaps the hypothesis has to be shifted or adjusted for uh, processes that require less water, or something along those lines, somewhere in between. I'm not sure, right? I'm at the point, I've been working on these questions and thinking about this for a long time, and I'm kind of sort of in that position where, like, I understand the physical and the landform evidence, but I'm also completely perplexed and flummoxed by how much water that requires.
Yeah.
And it's a question that goes beyond, like, you have to produce it, you have to store it, and then you have to release it. So that those three questions can all go together.
So if it's an ancient ocean, it was at least already there, although the Earth started to expand and released water, so maybe additional water got additionally added to the region before the Earth grew to enough of a radius to compensate for the new water, while the entire Earth was flooded in the global flood. And just added pressure to the region and swirled it. I'm not completely sure that there were glaciers. I guess I believe there were glaciers. I just still wonder if it's possible, if it was just moving and deep enough, had enough current, basically because the undercurrent of magma flowing from over here, of like a hot undercurrent flowing this way, under this crust, that then reached the ocean region, which had maybe a relatively thinner crust in a similar way, so it was already easier to heat exchange. plus it had water on it, and so it heat exchanged with the water, which then excited the water, and it started to like not boil per se, but like move, because it's just moving moving the water around, churning it, adding flow rates, adding energy to the water so that it can flow more than it was in a state like this. So there's the possibility that additional water was added, plus the heat was added for sure. As well as, because the Earth was expanding, there's a high likelihood that there was like a lot of heat and a lot of cold to counteract it. So it was interacting more with space, and the cold was really allowed in and chilled the water of the ocean that was over here to freeze it. I mean, it seems like glaciers were there. I guess I should just, like, hold that firm. I just don't know enough about why it must be that glaciers existed and couldn't be just large quantities of water that were deep enough, but and had the base region flowing with enough of a current. I guess if it was just water, it would probably allow the heat up more and the current would be up above. But with ice, maybe it holds that, it participate in holding the currents, I guess. I just wonder if like out here was beyond the ocean and it was more just overflow reaching out, but not affecting it in the same way as where the glaciers were. Although the glaciers did advance to different points throughout the process, so it was probably actual glaciers due to just heat exchange between the water and the space to really cool off the water enough to stabilize the earth from the expansion process. And all the heat that was being released by the undercurrents that were just like, Earth's like, I don't like this. That's so cool. If living ice flame, was it? Living flame of ice. These are odd. Like, they're not necessarily in the direction of the water flow. Like, here they seem at least somewhat like they could come off it. This is just straight counter to it. So maybe there's a flow going this way that holds a boundary for another flow going this way that gets squeezed into here. I don't see any, like, it goes this way, but then it's still going across here. This is going up. This is going over that way. I think I might be drawing the overall ones half decently, but it looks like they have a lot more nuance. I'm also wondering if it's doing it backwards somehow, where the flow is in the opposite direction to map, but this seems to make sense. But over here makes me wonder. Although then this would be a pinch point. It probably was above the water, I guess, above the ice, above the glacier. The glacier was like middle of this ocean, maybe. The top was hot enough that it was water. The bottom was hot enough that it was water from the heat exchange from below. But the middle actually froze. And it froze with openings like pores for the heat exchange from the bottom to the top, and vice versa. That then cycled, maybe? How cool is that? That probably is going on. To have a point like this, it almost necessitates an inlet that's not really present. I mean, we could say here, I guess. I guess it's going, but this is going opposing it. Opposing it. I guess it could just go in that way. But that's even opposing this, and this, and this. Whoa. This way, this way. Oh my god. They're in opposite directions. Hmm. It's almost like this spot. And then it had like a projection that way that it came off of. I don't know. Maybe the whole of it. This really makes me think of a shallogram. Like this kind of thing. Of course, none of them. Wow. I guess I don't have that many of the more normal looking ones. Here we go. this one. With like this region. That's incredible. It really seems like just a point of outward radiation from there. Oh my god, it really means that the glaciers existed in the midst of hot water. Liquid water above and below. Is that possible? Just enough heat at the top that it can't rise. Let's go Newton. Let's go Newton. 'Tis true without lying, certain and most true. That which is below is like that which is above. And that which is above is like that which is below. To do the miracle of one only thing. And as all things have been and arose from one by the mediation of one, so all things have their birth from this one thing by adaptation. The sun is its father, the moon its mother, the wind hath carried it in its belly, the earth is its nurse. The father of all perfection in the whole world is here. Its force or power is entire if it be converted into earth. Separate thou the earth from the fire, the subtle from the gross, sweetly with great industry. It ascends from the earth to the heaven, and again it descends to the earth and receives. I'm not sure if this is going to have the, like, thought-provoking things that I thought maybe it would by having that concept of a intermediary glacier between two hot layers that are exchanging by boiling up and just cold passing down enough to get into this intermediary layer. That would be so cool. uh receives the force of things superior and inferior. By this means you shall have the glory of the whole world, and thereby all obscurity shall fly from you. Its force is above all force, for it vanquishes every subtle thing and penetrates every solid thing. So was the world created. From this are and do come admirable adaptations, whereof the means is here in this. Hence I am called Hermes Trismegistus. Having the three parts of the philosophy of the whole world, that which I have said of the operation of the sun is accomplished and ended. Isaac Newton's translation, because calculus and physics do go with this. I don't know though. I was thinking maybe considering water from that angle might be useful in like what exactly is being said here. I don't. Every now and then I come back to it to see if some new realization is present, but I don't know. This time I was just excited that maybe there would be one. If there is one, I don't know. Like I see all the fractal nature of everything where like I'm looking at this like a hologram, but I still don't know what this like really means. I don't know what it really means. The earth from the fire. The subtle from the gross. Sweetly with great industry. This is an interesting thought. It vanquishes every subtle thing and penetrates every solid thing. That's very water-like. And as both Randall and Jerome Lessman have pointed out, there are regions where, like, maybe I can find it. Where there are just like boulders. I think this is it. Big boulders and then drumlins, and nothing smaller than big boulders, which means it got transported away by the currents. So these boulders indicate like the maximum current that was flowing because they got dropped there, or at least like how the current that they were dropped at was like a final current when this was passing through. I don't. But in essence, there's nothing smaller, so it's vanquished the subtle with high flow rates of water. And water penetrates every solid thing. I mean, that's. I don't know why interpreting. Let's see if we think of it from the angle of water. Let's do the miracle of water. As all things have been and arose from water, by the mediation of water. I don't think it's that basic, but let's see. So all things, I mean, sometimes it's how it works. Simple is what it is. It just seems confusing until then. That would be cool if it made complete sense from a water angle. So all things have their birth and then like shed light onto some other things from this one thing by adaptation. The sun is its father, the moon its mother. The wind hath carried it in its belly, the earth is its nurse. The father of all perfection in the whole world is here. Its force or power is entire if it be converted into earth. Water converted into earth. Like if everything else fits and then there's just like that's just like what? Maybe though, wouldn't that be cool? I don't know how. Separate thou the earth from the fire, the subtle from the gross. sweetly with great industry. Sends to the earth and from the earth to the heaven, and again it descends to the earth and receives the forces of things superior and inferior. I mean, that's water, but that's maybe, oh my god. Like, ether does that too. Behaves the same. Looking to water's behaviors are probably very useful for how ether behaves. Even if it's not talking about water, to even think about it from the angle of water, it ascends from the earth to the heaven, and again it descends to the earth and receives the force of things superior and inferior. Raindrops keep falling on my head. By this means, you shall force and above all force, for it is above all force, for it vanquishes everything. And from this are and do come admirable adaptations, whereof the means is here in this. This is the water. This is pretty interesting. Where it like goes across, runs into resistance. It's near the water boundary, although it doesn't seem to care about the water boundary mostly. It's almost like it's got like a shape like this from the currents, where one side it's not as affected, so it's just got this uplift, and then the other side's just getting hammered by the current, so it's got like a slope down, so it can come across it, but then it catches on the portion that's not been as affected as much, maybe, creating that horseshoe shape. Assuming there's a close relationship to the like presence of this amount of water to there being some kind of resistance to airflow. Kind of makes sense that if there's a large blob of water compared to just air, it's a little harder for the air to move, so it hit the blob of water and start to do things of this nature. That then would lead to it swirling around the blob of water. Kind of like, I don't know. I don't know. There's no like, exact thing. Maybe here is a little bit like that, swirling. In towards the center around there. It's a little blocky here. That's real interesting. Because essentially, right here, from here to here, there's nothing but this current There's no current flowing this way. There's a resistance over here, but it gets bent around and goes this way entirely. There's no currents making their way through there. Goes this way. This one goes all the way down. There's just nothing. It's fully protected here. And yet, it forms a swirl that this over here is trying to just go around it. But this vortex is creating a jet stream this way that's pushing this boundary out. So it's not like over here. Like over here, it's much more just going below and then back to be like similar where it was, just going around the obstruction. Here, the obstruction is inducing a jet stream off of it that's interfering with this current, and they're colliding enough, I guess, to actually create a backflow this way. Swirl in there and just have, I guess, dropping channels that this jet stream is running into enough resistance that they start to drop down. And maybe come back up somewhat, I don't know. Maybe drop down and then go underneath and then out this way. No. At that point, they're just going this way. It's like a portal from below there. Totally missing now, but does it again here, where it just the whole way, this whole stretch, it's creating this jet stream. It's pushing out this boundary of a current trying to go that way. That's highly informative to how shallograms form, I'm sure of it. Oh my god. A general current flow going like this way. There's another one of those. Let's drop lower. Whoa. That starts to swirl at a resistance. Runs into some kind of resistance like this. And then starts to swirl around it. I know there's more to it than what I'm saying, like, in terms of building the storm. It's not just like running into resistance. It's like that built over time. But generally running into resistance, flowing like this, at this point, that's what's happening at least. It builds into this, so it must have taken steps to get to a point where it had this structure, that it had like a bulge on this side and could freely flow atop it on this side, and then an eddy off of that. Coming in here, hitting, going this way. There's definitely ammonite mechanics in this. And probably the ice sheet. how the ice sheet was. How the currents of water are flowing here, here, over here, down this way, across this way, through this way, down this way, down this way, down this way, down around here, definitely through here. Okay, that's an hour. I guess I'll stop there. See you guys later. Peace out.